So very quickly go through the first slide, and then just as soon as we get that, so we can skip the one since you already introduced me. So let's get started with the workflow as a function flow as from the conceptual point of view, and maybe first of all, what actually led to starting to think about those kind of things. So I've been in the workflow area for around 15 years, a little bit more even. So it started always with the centralized big setup of the orchestrations or the workflow solution of process management and so on and so forth. And now it's starting to move towards more and more distributed setups, where you can even have individual activities of your workflow execute on different containers and so on. So what the idea with the workflow as a function flow was to start kind of in the middle of both. So it's not to be a fully centralized and not to be fully distributed, but have something in between to ease the adoption of workflows and use the workflow as building your business logic. So with that, the idea is that you start start building your business logic and your workflows as complete as possible. Obviously, it's not going to span across the entire organization, but individual parts of the organization or the business processes that you're dealing with can be modeled and developed as one thing. But at the same time, take the advantage of the distributed nature of current infrastructure and allow it to scale to much better than what it would do with a centralized and single execution flow. So with that, we can actually slice the business logic, meaning the workflow definitions, into functions that are self-contained, independent, but at the same time can be invoked at any time. And due to the fact that they are independent of each other, they can be scaled to pretty much no limits. And with that, taking a quick look at a simple example of a user registration workflow. And in this particular case, it's a flowchart kind of workflow. So that is based on BPMN, that stands for Business Process Model Implementation. But the overall concept of workflow as a function is not limited to that, and can be used, for instance, with the serverless workload specification based, like declarative workflows as well. Because in the end, it's actually to find out the individual pieces that can be extracted and made functions out of them and make them available for execution from different places based on incoming events. So how it's actually sliced into functions, the workflow definition, is based on an idea of executing activities. And executing activities means that the activity that performs some work that at the time when it's being invoked, it's unknown how long will it take, how much resources it will take, and what's the potential outcome of that, right? What will it produce? Only one outcome? Will there be multiple outputs of the execution and so on and so forth? That's why the executing activity is considered a starting point for a function. And as you can see here, we have three functions that are derived from the workflow definition. And to start with, that executing activities are, for instance, the verifying user data, because we know that we get the data from the certain source, but we don't know how long will it take to validate it. So that's why it's considered a function and can be invoked at any time from any place based on the incoming event. But at the same time, a switch in this particular case, a gateway, a decision point, or the control logic point, it's not really taking that much time to invoke. So it doesn't make sense to actually create another function for it, because we know that it's really tightly connected with the activity before it, because it will act based on the data it receives from the performing activity or the executing activity. And that's why you can see that there are individual parts like the generate username password, which again is non-predictable at the time when it's executed, because it might take milliseconds, it might take seconds or even minutes. So that's why it's considered another function and so on. But at the same time, you have full control of deciding what actually constitutes a function. So for instance, this notify invalid data, which is not really marked as a function itself, it is brought together with the previous one, and it's based on the configuration here. So you can mark a certain activities that is a continuation of the previous one, and by that combine that into one. This is again to optimize on the elements that really do not make much sense to stand as an individual functions, but can join the the previous function call, so to say. Lastly, what I would like to bring up to your attention as well is the ending of the workflow is a producing activity as well, meaning that it will generate the output based on the information it collects. So it might be end of one workflow, could be a start of another one, or it could integrate with other systems by simply emitting events and at the end of the execution workflow. So you can have a completely asynchronous execution and you will be notified with the output of the completion of the entire workflow instance as soon as it's done. Functions are named based on the activities or the workflow definitions themselves. So they are composed from three elements. One is the package of the workflow, the identifier of the workflow, and identifier might be a standalone identifier, it might be identifier with the version number. And lastly is the activity name. And all of those can be either taken as is automatically based on the workflow definition, but they can be explicitly set by users as well. So you have the full control again on the type of things that happen. What is the name of the function? What is the identifier of the function, and so on. So looking into more details around functions, there are actually dedicated entry points to the execution. So even though we model everything as one, and at the same time it's deployed as one image as well, but all the sliced elements of the workflow that became functions are individually and dedicated as entry points. Each entry point, and meaning each function, has an input. All the inputs are based on the cloud events. And at the same time, functions become things because they need to produce data. So they can produce either one or more outputs. The one or more means that at the time of execution, the definition of the workflow and the logic of the workflow based on the process data can switch or can fork into multiple paths, or we might be using a loop construct that will simply invoke multiple services or multiple function next. So all that information is associated with the function calls, but derived from the runtime and pushed again as events, meaning that if we split the execution into parallel paths, those all parallel will be submitted as new events and come back for execution as individual events being delivered by the broker. And every single function has a dedicated trigger, a Knative trigger with a filter based on the type attributes, and the type attribute is based on the identifier of the function. All of this is actually generated at the build time of your service. So the slicing of your workflow, the generating code for functions, identifier of the functions, and lastly, the manifest file that sets up everything for deployment to the Knative or the Kubernetes cluster is created at the build time and provided to you at as a starting point. Especially the manifest file is a starting point because it assumes certain defaults. So it might not be ready for every the deployment, or especially not for production deployment, but at least gives you the most important part are the triggers. So you have the information what functions are in the particular service. And as mentioned, everything, both input and output, are based on the cloud event. Defined and the input and outputs are based on the definition of the data of your workflow. Inside the workflow, you can define certain data objects that your workflow is going to deal with. And you have the options to classify the data as well. So you can classify data as input, as outputs, as internal, transient, and so on and so forth. So you have many options to define what is the data that you're dealing with and what is their context. At the execution time, each function will receive the cloud event, transform that into execution of the function, and produce outputs, again, based on the execution context, meaning state of the data of the workflow instance. All the functions use the type attributes as the link to the function, with one exception. I will mention that in a second. And the source attribute is the function that is actually being invoked. So if we call a function A, the function A will have the source attribute set on the output event as the function A, but it will produce with a type information that is for the next function to be invoked. So that's why we have the function flow driven by the workflow definition, but invoked through the broker. So all the things within the function flow do not talk to each other directly. They always publish and consume events through the broker. And here, I mentioned that there is one exception in terms of the type attribute, and this is depending on the type of environment we're deploying this to. So if it's a vanilla Knative environment where you have access to both sync bindings and the broker itself, then you can clearly rely on that information to produce the events. But for instance, in the Cloud Run environment, there is no direct access to the broker, and there is no sync binding as such. So that's why moving toward the PubSub instead there allows us to take advantage of the infrastructure, but at the same time requires additional information to be associated to link to the correct function, because the type attributes of the cloud events delivered by the PubSub on Cloud Run will always have the same type of event, which is message received or something. This is like the fully qualified name of that. And with this, we need to have the source attribute as well. And in the Cloud Run environment, the source attribute actually set to the topic that the message come from. And these two information together allows us to link to the particular function within the function flow based on the workflow. So enough talking, let's look at how it actually runs and what we can see out of that. So let me just grab quickly here. So it's the same workflow definition, excuse me, with exact same definition of the task. What I would like you to mention here is the actual business logic behind it. So it is about user registration, a really simple user registration process that requires to validate the data based on the received information, which is the email address, first and last name. We generate the username and password. Next, we check if the user already exists in the repository or the user repository. And in this particular case, we use the Swagger Pet Store as our user repository. And that's why you can see the error handling here, because the Swagger Pet Store returns 404 if the user does not exist. So we need to catch that, as this is considered an error code. And then if we have the 404, we can proceed with the registration of the user. Those are REST calls, and those are individual functions as well, as you will see here in the build process. We generate this user registration file, and we have the options to what is automatically generated. We have the sync binding, we have the service, and then for each individual function that was derived from, we receive we get the trigger definition. So with each type pointing to our workflow definition. So if we look at this particular case, which is the starting of the workflow, this type information is derived from the package name and the process identifiers that can be easily found here. We have the package name and the identifier of the process. So this is all composed based on the information from the workflow definition itself. As I mentioned, I'm the visual guy, so that's why I prefer the BPMN and flowchart-based workflows, but that's not the only one. We can have pretty much exact same functionality based on the serverless workflow specification. So in this case, it's a JSON format, but there is a YAML base as well. It has exact same capabilities. It has this exact same execution flow. And as you can see, we use the same for the Open API calls. So we have the Swagger JSON, which is the Open API specification, and that is the operation ID that we wanted to invoke to get the user or to create the user. Depending on which one you prefer, declarative or visual or the flowchart base, you have both options to apply the concept of workflow as a function flow. All right, so we have that covered, and let's get this going. So let me switch here. So as I mentioned, we have the the YAML file generated. As you can see, I'm actually taking it from there, so it's not like a customized YAML file for the deployment. And I'm deploying that to a Kubernetes cluster with Knative, both serving and eventing installed with the 0.26 version. So if we deploy that, we will get the information about all the resources created. We can just look at the logs as well. So as soon as it starts relatively fast. It's a Java based, but it is compiled to a native image with GraalVM and powered by Quarkus, as you can see in the logs. So it is quite fast to start, quite fast to shut down, and allows you to scale easily between different environments. So let me just go back here. We have the Cloud Events player that we can easily see the events flowing through the invocation. So let me just get going here. I'll just log into the cluster. Let me see. So I'm sending an event to the broker in a binary format, HTTP binding, with the information that I'm creating a user with email Mark Strong, first name Mike, last name Strong. If we just publish that, and if everything goes well, yeah, we have that information already collected. As you can see, it gets already registered. So it means that it goes through this path. So it goes here. The user was found in the Swagger Pet Store. And that is quite a random thing with the Swagger Pet Store. So sometimes you can get very frequently that it's already registered, or very frequently that it's constantly being successfully registered. But it goes here and ends the process. And lastly, you can see that the end event is actually producing an event here as well. So this is the type that was processing the already registered, but it creates a message here as well with all the information of the workflow that it produces there. So if we do the same and just once again, it goes there as well, so we can easily change the data. And let's say it will be not strong, but weak this time. And then this goes through and we have all the registration for the user, and now it's successfully registered. But I would like to bring up your attention as well. So here we have the identifier that is associated with the workflow, and that is allowing us to keep track of the execution of the workflow with the same identities. So with this particular case that I'm showing right now, there is no persistence attached to the workflows, but there can be persistence attached, and that's why you can have it with the state, because right now what it uses is what I call an event-based persistence, meaning that everything that is sent through the eventing is actually the complete state of the process of the workflow instance. And that's why it can at any single time receive or resume its operation just based on the information it got from the event. But if you have persistence enabled and you have a long-running workload definitions, even though they are still functions, you can easily get that going, because it will look up based on the incoming identifier to find out what is associated with that particular instance. And the nice thing with the identifier is that you can use that as a so-called business key. So that might be one of your business data that becomes the identifier of the instance. So it will not be your ID like this, but it will be something that is known to your domain. And with that, it's easier to not be specific that, yeah, the identifier needs to be something specific to the workload. It is then abstracting and it's hiding the workloads completely from the consumers of those events. Lastly, let me just clean those events. And if I just go back here and just let's look at one example I want to show you. So it's registration. Oh, so here what I mentioned is that each function can be invoked at any time. And as you can see here, instead of starting the workflow or starting the workflow at the beginning of it, I want to start directly at the register user function. So that is to bypass all those activities and just directly go here and either there or there. And this is exactly what you can do, because it's as easy as just sending the user register user, so we have directly register notification provided. So you can start at pretty much any time in the workflow. And of course, depending on if you have persistence, if you don't have persistence, if you properly associate with the identifiers, that might slightly differ. But the concept is that each function can be invoked at pretty much any time from any source. And if you need to scale out, because for instance, your functions that, let's say that the create user or the register user function takes seconds or minutes, or is very intensive when it comes to resource consumption, like CPU and so on. So you can have new instances of the service with all the functions in its scaling next to it and consuming those events and calculating or performing the operations behind the functions. All right, let me see. And lastly, so we have that. And if we just invoke another one with, for instance, missing data, then it immediately ends up with invalid data. So it just directly receives the information, performs the validation, and again ends up very quickly here. All right, and as I mentioned, that you can run that on vanilla Knative or Kubernetes cluster, or you can run that on Cloud Run. The difference is that you need to do a few configuration options. Actually, I can even mention that here I created pull request, so it's good to show based on that information. For the documentation, samplers on the community. So if we look at the Cloud Run, so one thing that you need to add to the project is dependency to switch to a different way of receiving and producing events that will be based on the PubSub instead of sync binding, and then configure your project of the Google Cloud to make sure that it connects to the right place and gets all the association with the security and service accounts and so on. So when you build that application, it has exact same capabilities, meaning it will generate or will create the function slicer worker into functions, but it will, instead of creating the manifest, the YAML file, it will create two files. One is the deploy and the other is undeploy, that will provide you with all the gcloud commands to create topics, triggers, event arc, and then lastly to deploy the application itself or the service itself. But again, similar concept as with the manifest file is that it will have like it will be a starting point. It's nothing that is ready for production. All the information like the change.me is taken from there. So if you provide your project ID, all the information will be filled in here properly. And as you can see, the main information is here. So the type is based on the message published, but the function requires two information. It is the message published as the type of the cloud event that is received, and then the topic name that the message came from. Because in that, with this combination, you can actually individually find the right functions to invoke, but it will pretty much perform the same way. Instead of going through the sync binding and publishing events directly to the broker, it publishes messages on the PubSub based on the information that it grabbed from it. All right, and let me see. Yeah, so that's pretty much it. Slightly ahead of time, but if you want to get more information, you can reach out to me or just or the Automatica project. You have the website, the QR code will take you to the website as well.